Hello everyone and welcome to another episode of the IPG tutorial series. In the previous episodes you should have gone through the basics of the IPG GUI, and this episode is going to be focused on using the link between Matlab and Simulink to IPG. So Matlab and Simulink is a great tool that allows you to control the motor characteristics and sort of performance and dynamics of the IPG simulation, and we're going to go through all that. I do suggest watching the previous video because that is the basics of the entire thing. I will be going over it again in this video to set up everything else, but it is recommended that you do watch the previous video. On that note, let's get started. So to start with, IPG actually provide SAE teams with this awesome package which has a number of FSAE examples that we will be using. So what I'm going to do is I'm going to copy this package into the directory that we have for the CM projects, and I'm going to rename this. So let's go tutorial, and for this sake let's say 1. Now let's leave that and let's open the CarMaker GUI. Lovely. So what we need to do is we actually need to go and select the new project that we just put in there, the tutorial. Because the files that IPG gave us are done with the previous version of IPG, not the 9.0 that I'm running here, it will ask me to update them. So let's update all the files, and it is crucial that we select the CarMaker for Simulink extras. And the Simulink coder. The other ones are not so much. I just like putting them in there because it does come up with a few extra examples. So we'll let that wait and finish. You should see soon the extra CarMaker for Simulink files and all that coming up. Yeah, so these are the things that you don't get with the normal IPG package that comes with this, that you'll be using all the time. They are so good. And here we go. Update successful. Cool. Now, that's pretty much it. We're not going to be doing the whole setup thing here because we haven't initialized it yet with the whole Matlab process. So let's exit out of that and let's start up Matlab. On a side note, please don't use the latest version of Matlab, the 2020 version. It does not link with the IPG, the previous versions of IPG. You have to make sure that you're using the right Matlab for the correct IPG you're using. Okay, so Matlab is a great tool. Let's move into here and go to the actual project that we're using. So tutorial 1 and the source files for the CarMaker for Simulink packages. Lovely. So this here is your directory. This is where everything that you are going to run should be. And just for a bit of consistency's sake, what I'm going to do is these example files that they give here, so the open Xwheel drive, the torque vectoring examples, the motor characteristics and the parameters, I'm actually going to copy and paste them into the main directory, and you'll see why in a second. So once that's done, let's minimize that. For this sake, I'm going to go with the generic model. So this should open up the Simulink model. It might take a bit longer for the first time because obviously it's a big file and has all the parameters that IPG are running. Lovely. So this is the perfect part, okay? Right here, you will see all of your IPG parameters, right? So you've gone from your vehicle control, this time, the brake percentage, the gas percentage, all that sort of signal information that's coming through. Generally, we don't muck around with that. You can to sort of show that the IPG is being controlled via the Simulink, but there are better ways. So right here, I'll show you the powertrain model. And in this case, you'll see all the torque drives for each of the wheels. And this will change depending on the model you select in your IPG. So like you've got front left, front right, rear left, rear right, torque supplied to bodies, your operation states, turning it on. Lovely. So now that you've sort of seen that, let's try and run a simulation. And this is now your interface with IPG. So you no longer open IPG through the command window, or like the Windows taskbar, we always open it through these models so that we know that they're linked. And as a sanity check, you can even run this cmnv file in here. Let's run this. Yeah, so these add paths prove that they are working. If any errors come up in here, it means these two files, these two programs are not linked. So let's bring back up the Simulink model. And yes, so we're pretty much going at a quick pace here. So I'm going to select the all-wheel drive model. Not that it makes a difference, you can select any of them. I'm going to put some random tires on the car. I'm going to obviously import a road. You would have seen this in the previous video. This is what I was talking about at the start, and obviously selecting a maneuver. Lovely. So what I'll do is I'll open IPG movie. It should come up in a second. Lovely. And let's get this happening like that. What I'll do is I'll close that too and open up instruments as well so that we get a good look at the whole thing. Okay, let's get this started now. I can actually run these two things and IPG through the Simulink package now using this top run command. So if I press run, then I'll get the instruments back up. Lovely. So we're now seeing that we're running. And this is great because now we know that, you know, the Simulink and the IPG models are working together and they are controlling one another. The next thing is to prove that we can actually make changes to the model and it will reflect in our actual simulation. So what I'm going to do is I'm going to go in here and I'm going to go to the powertrain model. Let's go to the library browser and commonly used blocks. And let's put a gain in here. Okay. Now, let's move it over and change this value. There are a couple of ways that you can start doing this. So I can actually click anywhere and type gain if I know the name of the block, the Simulink block that I'm after. If you don't, it's always very easy to go through the library browser up the top, similar to how I did it at the start. Let's put another one. Okay, so what we're going to do now is we're going to go through and all these drive variables. Okay, and really this is just so we can see whether or not we are controlling the values that are going through. So what I'm going to do is theoretically half the speed that the car should be going, or should be sending to the tires. Probably a better way of expressing that. Excuse me. Sorry. Yep. So that goes there. Goes there. Lovely. Okay, so now we know we've got 75.3 kilometers per hour, and the time on this was 7.89 seconds. This should be visibly slower. You should see the car slow down immensely with this entire setup. So we're just going to run it and we're going to see what sort of differences we're getting between the two. Okay, so we're still getting the same results, and that is expected. Okay, and the reason for that is, if I minimize these two, inside this car model, once it opens up, inside here, inside the powertrain, we're running the preset electrical model in the powertrain, okay, and with 4 electric motors. So our entire control unit is being run through the CarMaker GUI. The powertrain is not being controlled by the Simulink model. there are two ways that we can do it. So we can go in here and we can actually add models, and that model is a built plugin that we make through IPG, which is one of the ways of doing it. The other way is the Simulink, the CarMaker for Simulink user model. And to make our lives easier, what we can actually do is use the provided, give me 1 second, let's get out of all this. We can use the provided open Xwheel drive model that the FSAE project has given us. So I'm gonna not save that, and instead I'm going to open up the open Xwheel drive model. So this here is the thing that you get using by being a part of the Formula SAE program and having the SAE provided licenses. And as you can see, this function here actually overwrites the torque values that are going to the wheels. And in this model, it's only a rear-wheel drive car, but it's easy enough to make it a all-wheel drive or front-wheel drive, depending on what you want to do for your particular use case. So that being said, let's move out of here. Let's open up CarMaker GUI again through this new model. Take a second. Lovely. And now we can actually open up the open Xwheel drive model. Okay. And similar to the rest of them, similar to the rest of the setups, we're going to select all the general stuff in the GUI to run the simulation. So we'll just do it all the same again, just for consistency's sake. Lovely. Okay. Now, if I open up IPG Movie and Instruments, lovely, and we click Run, we'll do, open up Instruments again. Okay, so this error here is a common error, and the reason I wanted to show it is because we need to pay particular notice to what the error is. No entry to the powertrain drive source position file. What does that mean? Okay, so in order for the open Xwheel drive model and the IPG model of the open Xwheel drive to communicate, there at see here, first of all, just a side note, the open Xwheel drive, we have an additional parameters file. And this file here is the missing link between the two. It helps the Simulink model talk to IPG prior to running the simulation. So for us to be able to actually run this, we're provided with the specific code that we need. And this code allows us to, now that I've gone through that, sorry, I think I've saved the wrong part of it. Let's just double check. Yeah, okay, so let's get rid of this. You don't need that part. Lovely. So now that that's there, what we can try and do is run to see whether or not this is going to work. Lovely. So now we're at the stage of, obviously it's very, very slow based on the motor characteristics that are provided in the powertrain model. That's okay, we can fix that up very simply. We might even do it in a later video. But what we really want to show right now is that we are able to change the information. So have a look here. We've got 10 seconds it took to finish this whole track, and we hit a top speed of 50.3 kilometers per hour. If I change this gain value, now that we're running the open Xwheel drive model and we have the link between the open Xwheel drive and the IPG, we should be expecting this to take much, much longer than what it was taking now. So let's run this and let's see if we get that same result. Lovely. So already you can see it's visibly slower, which means the changes we are making in here are affecting our model inside of IPG, and anything we do now, that ensuring that we keep it, what's the word now? Had a mental blank. Ensuring that we keep it stable so that the car is not going to go off the track or obviously lose gravity. The important parts are showing that these two are linked and they do work. And that's pretty much it for this episode. So hopefully you've learned something. Hopefully you're at this stage here now and you're able to start mucking around with the Simulink and Matlab blocks. I do suggest going through these. These models and all this stuff in here is awesome. Inside the scope, let's put a scope in here. You can actually see, so I've just put a one port on the scope. Let's see what we get through this. If I run the model, I should be able to see what's coming out of this scope. Yeah, so what we're seeing here is the torque that is being sent to the rear left wheel, based on obviously the motor map and motor characteristics that are put inside this data. At the minute, obviously it's not the fastest thing, but at least we can see this data inside IPG and inside Simulink, which is really, really beneficial and will be crucial to us creating and testing controllers at a later stage. That being said, thank you for tuning in, and hopefully you learned something from this video.